This brings us to the last section of the course, section 3, which covers all of the fossils that are intermediary between apes and us and that we would consider on the map of human evolution, quite frankly. So let's move into the first part here in Module 11, covering some of the earliest hominids. We're going to talk about what a hominid is, and then we have some like potential or early hominids. And I say potential because some of them people have been discussing whether some of these fossils might be some type of ape that is not quite on our line or on the line to humans, or on the line to us, Homo sapiens. And so they are contentious, and we'll talk about some of those controversies. Here's a simplified hominid phylogeny. Now, what is a hominid? A hominid is any organism that postdates the split between chimpanzee, bonobo, and us. So that would be Pan and Homo. So you can see at the very top here, to the left, on one branch, we have the branch that leads to modern chimpanzees and bonobos. And then we have our branch, which branch Homo, and that's Charles Darwin, a picture of Charles Darwin here on the right. And that would be, on the way to our line, right? This is how conceptually we look at as some type of cladogram or phylogeny, similar to the living primates that we did in the second section. So we are predicting that there is a last common ancestor with us, Homo, and Pan, and we have a number of different fossils in between that share characteristics that are ape-like as well as human-like. We think that that last common ancestor with us and African apes is between 5 and 8 million years ago. So 5 to 7, 5 to 8, and it's represented here as MYA, so millions of years ago. So what happens is our lineage branches off and evolves away from the ape lineage. And this happens 5 to 8 million years ago, and then what you begin to see are early signs of creatures that have both ape and human characteristics that actually share them. And then you have the Australopithecines and the Paranthropines. The Paranthropines are like this kind of vegetarian offshoot, and we'll cover that in the third part of this lecture series. They're really interesting. They look like they have a very adaptive, highly adaptive chewing and mastication for specifically a vegetarian diet. And then the Australopithecines, they kind of, because the Paranthropines look more like these creatures like us, but they have more of a gorilla head because they have a huge sagittal crest, although they have front teeth that look similar to you. And then you have the Australopithecines, which we think are creatures that may have been experimenting with meat and possibly its other products like bone marrow and brain, and they have more of a chimpanzee-like head. These include the very famous fossil affectionately known as Lucy. And then so Lucy's on here in the red background as an Australopithecine. Lucy is Australopithecus afarensis, but there is another Australopithecine from South Africa, and that's a picture of the Tong child. So we'll cover the earliest hominids as well as the Australopithecines and Paranthropines in this video right here. Enter in a fossil known as Sahelanthropus tugensis. Each one of these species I'm going to talk about specifically will have a species profile, and on that, like right here, it'll have the scientific name. It will have some way to kind of remember the scientific name, and then who discovered it, when was it discovered, where can we find them, and how old they are. And sometimes there are nicknames for the fossils, like this one, which is only one cranium, no mandible or lower jaw, and has been known as Tumai. And it has been classified as Sahelanthropus tugensis, a completely different genus because we don't know exactly what we're looking at. And the way it was named, right? Sahel is an area of the Sahara, particularly the southern Sahara. and anthropos means human. So it is a human from the Sahel, and then oftentimes ensis is added on the species designation after the genus, and so this was found in Chad, so they named it Chadensis, and it was found by Michel Brunet of the College of Paris in 2001 after doing goodness, decade long or more of surveys of this area of Central or West Africa, and they found it in an area of Taurus Manila in Chad, and it dates to about 6 to 7 million years. This cranium, without the mandible is all we have. We only have one fossil. I think there might be some tooth fragments, and most recently, there was a report on some of the limb bones that were found that are attributed to this species or fossil. So things are heating up a little bit with Sahelanthropus tigensis in the academic world. People are talking about it again more. And so this is the one we'll focus on because it has the best evidence for bipedalism. So when you look at hominid evolution, those creatures that post-date that split between Pan and Homo, and that had to occur based on DNA between 5 and 8 million years ago. And the features of a hominid are specifically walking on two legs, bipedalism. So that's one way to identify a hominid. The other way to do it is the loss of the CP3 honing facet. So canine on the maxilla or upper jaw, and the first premolar on the mandible or lower jaw. Every primate that's living today has a honing facet. So that means every time a primate that's not you opens and closes their mouth, they sharpen their teeth. Well, that's lost in hominids. And of course, we have a few ideas as to why. But you can see that this creature, right, that's represented as a cranium, has a very small cranial capacity, about 360 cc's. It doesn't have these megadontia, very large teeth in the molars, which we'll talk about more. And they do have thin enamel-like apes, right? So I just talked about some of the ape-like features. And by the way, a chimpanzee has on average about a 350 cc brain, and gorillas are about 500. There are other later hominid features, like having this prominent brow ridge that's above the eye orbits, having a flat face, which is also known as orognathic, and then there is no honing facet. And the only evidence for walking on two legs or bipedalism is what's known as the foramen magnum, and that is a really big hole that's underneath the cranium that tells us about the orientation of the vertebral segments and the brainstem and the spinal column. And for the most part, this is fairly forward in its position, which suggests walking on two legs. Now, the problem is we want more of the skeleton. We want more material to confirm this, because then there are other features that would solidify that this is a creature that walks on two limbs on the ground. Now, we do notice that gibbons, siamangs, like the lesser apes, like the hylobades, they actually do have a more forward position on their foramen magnum, because they are upright with their chest and they are moving through the trees with their arms. So that's another part of the controversy, that this could also be some type of ape-like creature that does have a loss of the honing facet, but may not be walking on two legs on the ground. The only other early or potential hominid I want to talk about is Ardipithecus ramidus. And that's because this one is much more complete. And you can see that the picture on the right, affectionately known as Ardi. Ardi means ground, Pith means ape, and Ramidu means root. And so these were some of the words that were used to create the scientific classification for Ardipithecus ramidus. And the discoverer is one of the most prominent paleoanthropologists we have on Earth, who's known as Tim White of California, Berkeley. It was found in mid 90s and eventually described 10 years later. Did a lot of analysis. They have one volcanic ash layer that dates to 4.4 million years ago, and it's found in the same region we find Lucy fossils in this area of Ethiopia, in and around the Far Triangle. Now, they do have other material that dates to almost 6 million years that they've dubbed Ardipithecus cadabra, but it's only a number of different teeth, but it's from a different time frame. And Tim White's, many people respect his opinion. He suggests that there's actually two species of Ardipithecus, but this particular specimen, is a fairly complete individual, and then you can actually start to see more of what's going on in the big picture, and it allows us to ask all sorts of new, interesting questions. So, since much of the material is from one individual and it's fairly complete, now how much of it is preserved is a big question. The technology that was used is CT scans to kind of reconstruct the whole skull of Ardipithecus, and the cranial capacity is very similar to Sahelanthropus, as well as it doesn't have later hominid features like very large molar teeth or megadontia. Mega means large, dont means teeth. Later hominid features, though, having smaller canines, there's the loss of the honing facet, and it does have a smaller face or reduced prognathism. Right? Remember, orgnathic is a flat face. When you look at the hand morphology of Ardipithecus ramidus, a number of things stand out. One is their hands look very powerful for grasping, and they have curved fingers. This typically happens when you're in the trees. When you're grasping on round branches, your hands or your phalanges, which are the last segments of your appendages, right, that you can bend and curve for grasping. Ours are nice and straight because we live on the ground, and we're not growing up in the trees like many other creatures like apes do. And so this indicates that Ardipithecus ramidus either grew up in the trees or spent a lot of time in the trees. There are interesting features on the hand, like the absence of the types of morphology that we recognize with knuckle walking. Apes, right? Gorillas, chimpanzees, bonobos, on the ground, right? They're knuckle walkers, where they have these protrusions on their knuckles that allows them to put some weight on the forelimb and propel themselves forward using the hind limb. And so there's no indication for that. When we look at the foot morphology of the Artie fossil, and other things stand out too. If this is a hominid that has lost the honing facet, right, the sharpening of the canines, and we're going to put it in the hominid category, then it has to have these features that indicate bipedalism. Well, one that does not is of course the divergent helix. The big toe is used for grasping, and so this doesn't really help when we look at an argument for bipedalism, because the model for obligatory exclusive bipedalism, walking on two limbs, is us, and our big toe is in line with the other toes. We do not have grasping feet, so this is a much more ape-like feature. One of the most controversial aspects of Ardipithecus ramidus, the Artie fossil, is the pelvic morphology, the area of the pelvis. And so I've got a number of pelvies up here. You've got chimpanzees, which typically they're the blades of their hip bone or the pelvis. They're oriented towards the back. We'll talk about this more when we discuss the Lucy fossil. But you can feel your hip bone, the iliac blades on the sides. You can feel them easily on the sides of your hips. And In a chimpanzee, those are all the way to the back, right? You have to feel them reaching all the way in the back. Now you have some bits and pieces of your pelvis in the back, but yours is mostly oriented to the sides, and that's what the arty pelvis looks like too. It actually looks like much more like ours, and as well as Lucy's, and this infers bipedalism. But here's the problem: is there are areas of the pelvis in this fossil that you can see here on the left that they use CAT scan to reconstruct it is poorly preserved. I mean, there are areas of the pelvis that we just know in the morphology. The bone is just so thin. A lot of times, the pelvis doesn't even preserve in remains that are us, a few hundred years ago. So the pelvis is poorly preserved, and it's hard to accept the reconstruction of the pelvis completely outright. What the authors have done here is kind of reconstructed a creature that has the loss of the honing facet, but then it has these very primitive indicators for bipedalism that they termed facultative, that on the ground, there's no evidence for knuckle walking, so that creature must actually, um, you know, there's no indication that this creature is knuckle walking, so they had to be using maybe an upright posture and two limbs for contact on the ground. But they still had the ability to climb because they had the curved hands, and then you don't have any of the features that indicate, um, suspensory locomotion or knuckle walking. So therein lies parts of the issue. Some people suggest that this is a very primitive form of bipedalism, and we have to put this near the base of the split with Homo and Pan. Some people suggest that this is some type of highly derived ape that's not even our line. So therein lies the controversy.